Welcome to my channel. On the board we have solve 3 raised to power x minus the square root of 3 raised to power x plus 4 plus 20, and this is equal to 0. Now this is a Cambridge style mathematics question that tests your understanding of indices, powers, and logarithms. So we will need to carefully apply the laws of exponents and substitution to solve this problem. Okay, so solution. Let's begin with our solution. Now, here we have the square root of 3 raised to power x plus 4. Now, one of the laws of indices states that if we have a raised to power 3 times a raised to power 2, we can take one of the base and add the powers. Okay, so that is what is playing out here. So we can separate this base and then distribute the powers to each of the base. Okay, so let's do that here. Here we have 3 raised to power x minus, so I'm going to separate this base, okay, minus the square root of 3 raised to the power x times the square root of 3 raised to the power 4 plus 20, and this is equal to 0. So what I did was just to split the base and then distribute the power. So if you pick one of the base, you will still have this, okay, according to this law of indices. Now, I want you to recall that when you have root 3, you can express root 3 as a base that has a power 1 over 2. Okay, so root 3 is the same thing as 3 raised to power 1 over 2. So this can be expressed like this. Okay, so here we are going to have 3 raised to power x minus, here we have 3 raised to power 1 over 2, and then I raise it to the power x. Okay, and this is going to give us 3 raised to power 1 over 2, and then raise it to the power 4 plus 20, and this is equal to 0. Now looking at this, we have 3 raised to power x here, and we also have somehow 3 raised to power x over here. We are allowed to switch this exponent. Okay, we can bring x in and take the 1 over 2 out. We are allowed to switch. Okay, so let's go on. So here we have 3 raised to power x minus 3 raised to power x raised to power 1 over 2. So I have switched the exponent. Okay, and this is multiplied by 3 raised to power 1 over 2 times 4 plus 20, and this is equal to 0. All right, so here we are going to have 3 raised to power x minus 3 raised to power x, okay, multiplied by 3 raised to power 1 over 2. 1 over 2 times 4 is 2. Okay, that's going to be 4 divided by 2. So we're going to have 3 raised to power 2 plus 20, and this is equal to 0. Now, this is equal to 3 raised to power x minus 3 raised to power x raised to power half, okay, times 3 squared is 9 plus 20, and this is equal to 0. Now, looking at this, here we have 3 raised to power x, and here we have 3 raised to power x raised to power 1 over 2. What we have here is 2 times what we have here. Now, I'm going to prove it before we proceed. Now, if you take the reciprocal of this power, this exponent, and multiply it by this exponent, you're going to have this. And if you do the same thing, okay, let's do it together. So here I have 3 raised to power x, okay, raised to power 1 over 2. If I multiply this power by the reciprocal of 1 over 2, which is 2 over 1, okay, these 2 and this will cancel out, and I'll be left with 3 raised to power x. You can see that this is 2 times what we have here, okay? Now, at this point, we can apply substitution method because we have 3 raised to power x here, and we also have 3 raised to power x here. So let's choose what variable we are going to use. We can use any variable. We can use x, we can use y, we can use whatever variable we want to use. So let's go with y, okay? So we're going to say let y be equal to 3 raised to power x raised to power 1 over 2. Okay, we are going with this. Remember, this is 2 times what we have here. All right? Okay. So this is also equal to 3 raised to the power x over 2. So what I did was to multiply. I just multiplied the exponent. So x times 1 is x, and then we have 3 raised to power x over 2. Now, remember that I said from the proof, what I proved earlier, that this is twice what we have here. Okay, so then 3 raised to power x is now equal to 3 raised to power x over 2 all squared. Okay, this is twice what we have here. That is why I wrote this here. So 3 raised to power x is equal to 3 raised to power x over 2, which is what we have here, raised to power 2. So this is equal to y squared. Remember that our y is equal to this and equal to this. And 3 raised to power x is 2 times what we have here. Okay, so let's substitute our y into the equation. Remember, 3 raised to power x is now my y squared. And then 3 raised to power x over 2, okay, which is what we have here, is my y. All right, so here I'm going to have, substituting y into the equation, I'm going to have y squared, okay. The whole of this is my y. Y times 9 is minus 9y plus 20, and this is equal to 0. Now, this is a perfect quadratic equation, and we can go with the factorization method, yes, because we can actually factorize. Okay, so let's see. We need two factors such that if we multiply, we're going to have plus 20. And if we add, we're going to have minus 9, which is the coefficient of y. So the two factors are minus 4 and minus 5. Minus 4 minus 5 will give us minus 9. That's minus 4 plus minus 5 will give us minus 9. And minus 4 times minus 5 is going to be plus 20. Okay, so let's substitute or let's factorize using these factors. So to do that, we're going to open two brackets, one here and another here, and all will be equal to 0. So we have our y here and one y here. And then we use our factors. So here we have minus 4 and minus 5. Okay, and everything is equal to 0. So here I have my y minus 4 is equal to 0, or y minus 5 is equal to 0. So if we transpose minus 4 to this side of the equation, we're going to have y is equal to 4, or y is equal to 5. All right? But recall that our y is equal to 3 raised to power x over 2. Remember, our y is equal to 3 raised to power x over 2. So we now have to substitute the value of y and then solve for x. Now, at this point, we will use the values of y that we've gotten from our substitution to solve for the values of x. Okay, so for y equals to 4, we are going to have 4 is now equal to, repeat this, 3 raised to power x over 2. Okay, we are working with the first value that we got, first value of y. Now, at this point, we have to introduce the logarithm. Remember, I said that at the beginning. So the easiest way to do this is to work with log base 3. So I'm going to introduce log base 3 to both sides of this equation so we can find the value of x. So on the left hand side, we're going to have log base 3 of 4, and this is equal to log base 3 of 3 raised to power x over 2. Okay? All right, so the next thing to do is whenever you have an exponent in your logarithm, you are allowed to move it over here. Okay, so we are going to have log base 3 of 4. This is equal to x over 2 log base 3 of 3. Okay, now log base 3 of 3 is equal to 1. Now we are going to have log base 3 of 4 is now equal to x over 2 times 1. X over 2 times 1 is the same thing as x over 2. Now, what's the next thing to do? What we are looking for is just the value of x. We are going to multiply both sides of the equation by 2 so that we can get rid of this number 2. So let's multiply both sides of the equation by 2. So here I have log base 3 of 4 times 2 is equal to x over 2 times 2. So this and this will go. Now our x is now equal to 2 log. That's the first value of x. Now let's go on and solve for the second value of x. So for y equals 5, remember the second value of y was 5. We are going to have 5 is now equal to 3 raised to power x over 2. And we are going to do the same thing. We are going to introduce the logarithm at this point. And we're going to introduce log base 3 on both sides of the equation. So here I'm going to have log base 3 of 5. This is equal to log base 3 of 3 raised to power x over 2. Now, like I said, we are allowed to switch this exponent, okay? We are allowed to move it to this side. So now we're going to have log base 3 of 5 is now equal to, so bringing the exponent this way, we have x over 2 log base 3 of 3. Now when the number in your log is same as the base is equal to 1, so now we have log base 3 of 5 is now equal to x over 2. Now to get the value of x, we have to multiply both sides of the equation by 2. So now we have 2 times log, and this is equal to x over 2 times 2. So this and this will cancel out, and we are left with, so our x is equal to 2 log base 3 of 5. So this is the second value of x, and this is the first value of x. Thank you for watching. Please do like, share, and comment. I will see you in my next video.